This video is on simplifying radicals. To simplify radicals, you need to determine what perfect squares are in that number. The easiest way to do that, especially if you cannot recognize perfect squares, is to do a prime factorization tree. So you're going to go off to the side and you're going to start with 200. To do a prime factorization tree, you're just going to keep dividing until you have all prime numbers. So the first prime number that you divide by is 2. So 200, and then you're going to divide by 2, which gives you 100. 100 can be divided by 2, which gives you 50. 50 can be divided by 2, which gives you 25. Now we reach an issue. 25 is not divisible by 2, so then we just keep going up the prime numbers. It's not divisible by 3, but it is divisible by 5. So we're going to divide it by 5, and we're left with 5. We do not put a square around this 5 because it is part of the prime factorization. So now what you do, because we're finding perfect squares, squares meaning pairs, they're groups of 2s. If you were doing cubes, you would need groups of 3. So I'm going to circle my pairs, and there's 2 of them, 2 and 5. So what happens is you take 1 from each of those pairs and you multiply them together. So you're going to take 2 times 5, which is 10. That goes on the outside of the radical symbol. And then what's left is this 2 right here, and that's what goes on the inside. So one way you can look at this is if you had 200, 200 is 100 times 2. Well, the square root of 100 is 10, so that comes out, and then you're left with 2 inside. So either way, you simplify this radical to 10 radical 2. Let's take it a step harder. We now have variables in it. So let's go ahead and simplify the square root of 50 by doing a factor tree. So we have 50, and then we can divide that by 2, which gives us 25. And divide that by not 2, because it's not divisible by 2, or 3, it's divisible by 5. And so we realize we have this pair here, and that's it. So numerically wise, we have a 5 on the outside and a 2 on the inside. But what about these variables? Well, we have x cubed. So I'm just going to come down here and I'm going to write x times x times x. Well, so here's my pair. Pair comes out, and what's left stays in. And lastly, we have y. So y times y, well, there's a pair, so that comes out. And then technically there's a 1 inside, but 2 times 1 is 2, so you don't have to worry about putting the 1 inside. So my prime factorization of this is 5xy, or radical 2x. In our last example, we have the square root of 80, a4, b5, c7. So we're going to go ahead and prime factor the 80. So divisible by 2 gives us 40, divisible by 2 gives us 20, divisible by 2 gives us 10, divisible by 2 gives us 5. And so we're going to go ahead and pair these up. We have 2 pairs of 2's and then 1 5 left over. So 2 times 2 is 4, and then there's a 5 inside. Let's go ahead and do the a's. So it's a to the 4th. Well, one easy way that you could do variables is, so thinking of this, technically there's a 2 out here because it's the square root. If it was a cubed root, there'd be a 3. So what you could do in this case is just take this number divided by this number, and that's what would go on the outside. And if there's any remainders, they go on the inside. So a to the 4th, so 4 divided by 2 is 2, so it would be a squared. And to show you in the other way we did it, we had a, there's 4 of them. So there's 1 pair, 2 pairs, so a times a is a squared. So now let's try the b. We have b to the 5th. Well, 5 divided by 2 is a fraction. But if we take 4 divided by 2, we get 2. So b squared, and then there's 1 left over. And again, b, 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 because there's 5 of them. And we circle our pairs, 1, 2, so b squared, and then this b goes right there. And so lastly, we have our c's. So c7, so 7 divided by 2 is 3 with 1 left over. And so just to show you guys, C, 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 because there's 7 of them, 1 pair, 2 pair, 3 pair with 1 left over. So C times C times C is C cubed, and then 1 C left goes inside. Just a couple of reminders here. Simplifying radicals is removing the perfect squares from inside. Squares means pairs or sets of 2. To do this, prime factor tree the number and variables inside of the radical, circle the pairs, multiply each pairs together, this goes outside of the radical, and then everything uncircled gets multiplied together and stays inside of the radical. Now it's your turn to try some. Number 1 is the square root of 72x cubed. Number 2 is the square root of 100x to the 4th, y to the 7th. And number 3 is 98, or the square root of 98x to the 5th, y to the 4th, z to the 8th. Please do 2 of the 3 problems. Good luck!